Okay, welcome everybody. Thank you for making time for this session on your lunch hour. My name is Sarah Albin. I'm the Director of Marketing at EOS Positioning Systems. We see a lot of familiar faces, but if you're not yet familiar with us, hopefully you'll get to know a little bit more about what we do in this session. We have three awesome speakers sharing the stage today. First, we are going to have Jeff Shaner. Jeff is the Senior Product Lead for Field Apps at Esri. He's got over 28 years of experience building software products at Esri. And Jeff is going to talk about the latest developments in ArcGIS Field Maps. Next, we have Eric Gackstatter. Eric is the Principal GNSS Consultant at Discovery Management Group. And Eric has worked in high accuracy GNSS for over 30 years. He's going to talk today about what's new in the world of GNSS, with an emphasis on practicality in the field and GNSS signal updates. And then finally, we've got Jean-Yves Lauteur. Jean-Yves is the founder and CTO of EOS, and Jean-Yves is actually credited with creating the world's first Bluetooth GPS receiver that can provide 1 centimeter accuracy to any mobile device, including iOS. So Jean-Yves is going to talk today about what's new from EOS Positioning Systems, including some hardware and software updates. And with that, I will give the floor to Jeff.
Thank you, Sarah. So Sarah said that I've been with Esri for 28 years. I'll just preface that also with, I'm only 35 years old. So started a bit young, child genius. But I want to talk to you today briefly about what's new in ArcGIS Field Maps, spend a bit of time on its capabilities, and then hand it over to these guys. How many people here are using ArcGIS Field Maps today? Wow, like everybody. Okay, so I don't really need to explain too much. I'm done. Thank you. One of the key things about ArcGIS Field Maps that I'll mention is that we don't just look at it as data capture. Sorry about that, Johnny. I know that's really important and stuff, but it's more of a comprehensive system. So we've been pulling together capabilities of multiple products together to build field maps, and we look at it as your primary application from Esri to enhance awareness for understanding your data in the context of where you are. Being able to have your data talk to you using concepts like geofencing, being able to support the recording and sharing of your location to also enhance situational awareness. And we've got a lot of exciting new things coming early next year to talk about too. And to pull all that together, we really have two aspects or two parts of the system. We have the Field Maps Designer web application, which is new for those of you that maybe have come just from using ArcGIS Collector in the past. It helps you author maps, configure application settings so that you make the most out of the experience that your mobile workers have to go through. And that's kind of an iterative process, right? You want to define the maps as best you can, but then you're going to deploy them, you're going to learn more from your mobile crews, you're going to come back, you're going to tweak it, and it's a lot of back and forth. So we introduced the Field Maps Designer as a way to kind of lower the bar of entry to get going with your projects. It also is the framework by which we're delivering a lot of the new capabilities that come into the system, and also keep it simple for the mobile user as we add more and more to it. We've been doing a lot of stuff since we got together last year. Here's just a list of some of the enhancements. Know that we release at a cadence of every ArcGIS online update. So last year, we released in June just before the Users Conference then. Then we released in November. We had an update in February. And then we've had one also in June. And in the June update, I'll just highlight a couple of the key things there. We introduced support for field maps on Windows 11 devices. So we're leveraging our existing Android application in that effort. We didn't rebuild field maps in .NET or anything crazy like that. Windows 11 introduced something called the Windows subsystem for Android. which is a virtualization environment on your Windows 11 device. And with that came some, I don't know, challenges, I guess, that we had to overcome to bring all the capabilities of field maps to that device. And one of those was support for external GNSS receivers. So as you are likely familiar with ArcGIS Field Maps today, you can set a location provider based upon what's been Bluetooth connected to your iOS or Android device, and then if you're working with an RTK network or whatever, define a location profile. Because this is a virtualization environment, there's no Bluetooth support. So we needed to introduce a TCP IP connection, but we worked really closely with Jean-Yves and his team to bring that to life. Do you want to talk a bit about that, Jean-Yves?
Yes, after 15 years of waiting for you with our TCP client, it's her. No, it's good. It's a very good initiative from Esri to leverage that feature of Windows 11, which is a Windows subsystem for Android, where you can run actually Android apps on Windows devices. So EOS Tools Pro, if you guys are familiar with EOS Tools Pro, we have it on iOS, Android, and Windows. And on Windows, the way we did it is that we created a TCP server, so we do all the data handling when it comes to data offsets. We do GeoRead models and any changes we have to make to the data. We push it out to a TCP server local to the device because I think that WSA does not allow us to use the virtual component that we create. But at the same time, then in this case, the field maps now incorporate a TCP client that simply reads the stream of data from EOS Tools Pro. So the limitations are that you cannot run this on ARM-based processors. So you buy a new Surface Pro 9, buy a 64-bit processor. But we're working on getting a 64-bit, an ARM processor version, which is very uncommon usually, for EOS Tools Pro also. I don't know if you have this problem, this limitation with field maps running on ARM or...
With core Windows location, no, but any external receiver.
Right.
Yeah.
So it is ready today. So if some of you are on Windows and want to give it a try on tablet, Surface Pros, or any other Windows machine, but it has to be Windows 11, not Windows 10.
Yes, that's correct.
Right.
The Windows subsystem for Android is only on 11.
Windows 11.
Yeah.
All right.
A couple other things we did in the June release. A couple of new collection settings that people have asked us for. One is the GPS fixed type threshold. So we want to make the life of the mobile user hell if they don't get the accuracy we demand out of them, right? Yeah, because that's what we want, is to make people's life hell. So we introduced this new setting, which isn't on by default, so don't worry about that. But you can define what the fixed type threshold should be. So say you're required to get RTK fixed while you're capturing underground assets, and you lose that and it goes to float. We can prompt, if you enable the setting, to warn the user, hey, you do not want to collect, you've lost your fixed, RTK fixed type, fixed type. So that's just a warning message. So it's not that bad. It's annoying. No one likes notifications that are constantly bothering you. But it'll help you ensure that data has a certain accuracy when it's captured by GPS. The other setting we introduced is something called manual locations. So, with field maps, you can use GPS or you can use the map. And the way we define a manual location is if you move the map around and just tap to place that vertex or point location. That's a manual location for us. Now, if you were also to snap to an existing point, we don't consider that a manual location because that existing point could have been GPSed, right? So there's a little bit of a caveat on how we define a manual location. It also can present this really nasty warning message, but you could also block people from doing that now. So if you don't want them to use the map to collect things, like Eric's going to sit at the pub and he's going to do all of his data capture there by moving the map around and trying to fool us all. Now we can stop him from doing that and making sure that he's actually using the GPS and has to go out to the field. Okay. Yeah, I didn't like that one too much.
I'll figure out a way around it.
Geofencing, we did a little bit of an update. It was shown off in the plenary. You can really control the message most effectively using an arcade expression. You know, an example of that is I want to notify someone that is coming onto the Esri campus between 9 to 5 that they have to go check in and build a queue. But if it's after 5, they need to call this number. Well, you can build that logic into an expression and provide that message based upon knowing what the daytime is, right? So some advanced features that come through Arcade, that's a good example of one. And a few other things, like there's more advancements to the logic and forms there too. I do have some slides on the capabilities that I'll go through really quick. On the planning and coordination side, this is really where the Field Maps designer comes to life. And if you haven't started to use it, I really encourage you to do it because, like I said earlier, this is how you can control the experience that the mobile user has. And that could be, you know, different tools in the application. It could be the form definition. Go to the next slide here. It could be a lot of different things. We're controlling inside of the Field Maps designer the offline experience, what the forms experience is, that geofencing experience, also the data collection settings. You can set them up so that your mobile users don't have to set them on the device itself. And you can do it at the map level as well, so you can change those settings for different maps. And we're going to bring much more. I'm going to talk about that briefly in the road ahead. So think about how you can take advantage of the Field Maps designer to really bring that experience to life for the mobile user. Maps, we think maps are kind of important at Esri. I don't know if you knew that or not. So we're putting a lot of effort into Field Maps around maps. It's part of the name, actually. With maps, there's a lot of advanced capabilities that can help increase awareness. The location sharing provides the opportunity for you to not only record where you are, but broadcast where you are and record where you've been. And you can configure that too. And we've got a lot of organizations that are using it for security operations, for worker safety. I'm going to show you an example of that from a worker safety perspective in a second. But the map itself and the way you configure it really brings the application to life. And pop-ups are a good example. If you didn't know that, and I hope none of you are showing object IDs in your pop-ups. If you are, I'm going to find you. But define what that pop-up looks like. That is how you present yourself for a map layer. You can do charts in there now if you want in Field Maps. So, and you can use Arcade that will go off of other features and show you information. Like, I tap on an asset, show me the last 3 or 4 inspections on that asset that might have failed through related tables that have been edited. All kinds of amazing things you can do there. We've added support for indoors and outdoors use. We've added support for linear referencing, a whole bunch of stuff. Let me show you this geofencing demo. This is a customer of ours in Germany. I don't speak German, maybe some of you do. But the company's name is Voestalpine. Now what this guy's doing, he's walking up to what's called, I believe, a slag pond. Inside that blue polygon, he started to record his track. So only once he got inside that blue polygon and started to record his locations. And he's approaching the red polygon. And then once he enters that red polygon, that's the dangerous area. And it's going to make some kind of U2 message that says Achtung. So if you speak German, maybe you'll understand that. It's basically saying, heads up, you're in a dangerous area. He's going to go off and he's going to leave that dangerous area. And he'll get another message that he's left it. And then when he leaves the overall project space, it'll turn off location sharing. So that's just kind of one of the capabilities independent of like data capture that Field Maps can do. And obviously, he probably shouldn't walk across the road holding his phone. So if he had a peripheral like an Apple Watch, he could prevent himself from getting run over and just get that kind of haptic feedback rather than getting hit by a car. The location sharing, key capability, mentioned that a few times. It works offline, works connected, records locations. We use a combination of location services, but also the motion and fitness APIs in your device. So not only do we get the position information, we get the activity you're engaged in. So we know how much time Johnny was sitting versus how much time he's walking and how fast he's driving, potentially too. So all of that gets stored with the data, and you can use it as analytics if you'd like too. And we've done a bunch of things recently with that. Obviously, there's privacy concerns around recording and sharing locations, so it's an opt-in experience for the mobile user. Once again, we can make their life a little bit hell. We can say you have to turn it on in order to use a map. And then we can categorize the map with some string value for us to query it out after if you want. And you can configure a lot of different settings about how it's uploaded and all that stuff. On the data capture capabilities, what we've really been focusing on, and it's been a lot of our combined efforts with some key customers that we've had together with EOS that have driven a bunch of the work you see here. The collection settings that I talked about being one, the support for summary statistics of GPS metadata for lines and polygons, knowing like the worst fixed accuracy, or fixed type, or worst accuracy. All that stuff is stored now for lines and polygons. And all the forms work that we've done. You know, the use of Arcade. How many people are using Arcade today? As GIS professionals, if you're not starting to learn Arcade, I really recommend that you do it, or you go find someone that has and hire them, because Arcade is all over our system. And with this forms effort, what we've been doing is it's not just for field maps. We've become the authoring environment for it, but forms are stored in the web app. They're also in our JavaScript API, and they're also in our developer tools, the new Maps SDK. So as we move forward, like right now, the forms you author in field maps in the designer are used in the map viewer. They're used in the edit widget in Experience Builder. We're teaching ArcGIS Pro about forms, so we'll be form editing in ArcGIS Pro. Next year, we're going to release a new web editing application in ArcGIS Online. So forms are coming across the system architecture. And they're all predicated on Arcade. So learning Arcade is going to be very important, not just for making pretty maps, but how you work with your data too. Integration. Integration with location providers is how Jean-Yves and I work together. We're well integrated. The way that we do that today with EOS Tools Pro application and field maps is using universal app links. So if you're using Derek Reich's laser rangefinders to do offsetting capabilities, those all come to life through this app integration that we have with EOS Tools Pro. So you can take the really basic data capture capabilities that we have in field maps and do offsetting. And Jean-Yves has extended that to do underground locating, and I think he's probably working on other things that he doesn't tell me about either. And that all comes to life through this integration. But at its core, you know, we both on the iOS, Android, and now on the Windows platform have integration of location. Yeah, that's kind of where it all started. Forms, I've been talking about that for a while. The one thing I did want to mention beyond all of that is mobile device management. Does anyone here use a mobile device management system today? How many of you are going to, that you can leave your hands up, have your organization manages it, purchases the devices? I want to see if there's a big difference. A number of you. Okay, mobile device management systems are very effective when the organization manages the devices for you. It's the way that you can deploy updates to our system, but it's also a method by which you can configure capabilities of our system. And that's done through what we call application configuration keywords. And we've worked together on some of that too. So imagine, you have a setup for, you know what location profile you need to work with in field maps. You're always going to work with an EOS receiver. You have a number of settings, maybe you work with ArcGIS Enterprise versus ArcGIS Online, and no one wants to enter that portal URL. That's horrible inside of field maps. All that can be pushed to the device as what we call application keywords. And we work together on that stuff too, right, Johnny? And I think you want to talk a bit about that as well?
Yeah, but before I'll go back probably to the integration that we do with Esri. With so much arcade and field maps, what we're doing for more integration is pushing more arcades, Pitfall, Qbert, Pac-Man, Millipede, Centipede. That was funny.
That's just another level.
No, some of you are not as old as we are, playing arcades at university. So when you said my name, you woke me up from my dream, arcade. I was thinking about all this. So MDM. Regardless of how big the organization is, whether it's the medium size, large size, sometimes you want to streamline if you have one person in the company taking care of tech support for field technicians, you just sometimes don't want to hear it. You want to do other things. So MDM really helps there, where you can predefine a whole bunch of configuration ahead of time and push it to the deployments in mobile devices in the field. It's less complicated than you think. And it's doable by, I would say, any size organization also, because a lot of the tools to deploy, I think they're even free to deploy them. So what we decided to do is basically, MDM, what it is just a whole bunch of scripting that you have. We give you the basis in the file, you can modify what you want. So some of the features, for example, you want to predefine the alarms that you're going to get, and then you can have a profile, you can have the default values for the user, and you can lock certain fields so that the user in the field do not change them. So calling you, say, wait, what's my password? So you can put all this already predefined in an MDM. So we have done that for iOS first. It has been developed for Android, not released yet. Probably will come later in the summer or in the field, where MDM deployment will also be available on Android. Windows, we have no plans yet for that, but eventually, if there's demand, we will incorporate that also for Windows. And also, to make your life easier, MDM is basically XML files that you program, and you make mistakes. One typo and here it goes, it's not recognized. So what we are doing right now is creating an MDM wizard, an MDM generator for you. So on the website, you'll be able, if you have an existing XML, you'll be able to import it into the web interface. You'll be able to edit it or create a new one, and then save it to an XML file that you can use now for your MDM deployment. So you're going to have pull-down menus. You're going to have fields that you can unlock to allow the user in the field to edit those fields or not. And then it's going to be for quick deployments. I think it will make the life easy instead of writing codes, just to have a pull-down menus with the various categories. So this list of MDM will evolve. We have all the documentation online on our website. And at any point, you can give it a try. It's free. Those of you who are using EOS Tools Pro for iOS, you can, online directly, on the knowledge base, I think, or support, you'll find the MDM, or just search the website for MDM. And there's a very good presentation tomorrow by Indiana American Water, Randy Winston. He's giving a presentation, the name of the presentation is 10 miles long. Give me a second, I need to put my glasses to see that far. All right, so it's called Leverage Mobile Device Management to Streamline Field Data Collection. And also it's Mobile Workforce Optimization. So basically, Randy will show, it's 1 p.m. Grand Ballroom 6 Marriott. So Wendy will show how he did it for field maps and EOS Tools Pro, and the benefits that he got, challenges probably that he found, and how he overcame them, and then the benefits that he had in the deployment also. So I would really encourage you, if you want to learn more about the MDM, his presentation is very complete. It's very good also. I have another one.
No, it's back to me. Sorry, I'm just about done, I promise.
Yeah.
This is just a list of the Field Maps app configuration keywords that we support with MDMs. I wanted to talk briefly about our next release. So we've got another release coming this year. It'll be in October. This release is going to focus more on that designer experience than anything else. And really, you could think about it as quality of life improvements overall. Like I mentioned, we've supported getting started by creating a map inside of the Field Maps Designer. We affectionately refer to designer's value as eliminating the ping pong effect of going between all the different web apps inside ArcGIS Online. It can get complicated and you can get lost. So the more you can do in one app, the easier it is. So right now you can create a map, you can add layers, all that stuff. We're going to kind of round out that experience with some new capabilities there. And button up a few things we haven't done with form authoring. But we're also at the same time working on a pretty major update to Field Maps on the mobile side. We're going to introduce a new planning and coordination capability. We're going to start supporting offline utility networks, offline attribute rules. And to really bring that to life, we're modernizing the Field Maps architecture with the new versions of the Maps SDK. Just to dive a little bit on the planning and coordination bit, this is going to replace the product we know as ArcGIS Workforce. So if you've used ArcGIS Workforce, this is going to be a new capability for your Field Maps users to have a digital to-do list on their device. The way that'll come to life is in the Field Maps Designer. You can add a new tasks layer to your map. Tasks could be points, lines, areas. They can have a form associated with them that you have full control over, so you can extend it with whatever fields and form elements you want. And then you'll be able to lay out the logic behind all that form, and this is another place where Arcade's going to come in. So you're going to have control over the different types of status of work. So that's something we never let you do in Workforce either. And then with each iterative part of the status, like from design to in progress to completed, you can choose what tools and behavior happen as that status changes. So all that will be configurable in the designer and executed in the mobile application. And one of the big things there that we're not going to do, at least not in the short term with the tasking capabilities, is force a dispatching web app down your throat. So because it's founded on the feature service and the form capabilities that have evolved so much, you can build your own. You can use Experience Builder, you could use an instant app, or you could just use the Python API. So we're going to make it very open and easy for you to create work that can be assigned as part of someone's to-do list. And then also let you use the mobile app to do that too, by default anyway. So, you know, if I'm doing an inspection and I notice something else that needs to be done, well, I could create a new task that assigns to myself that could then be filled out later and maybe added to a work management system if you're doing integration with it there. Also, which probably never happened with Jean-Yves, but he might finish his work at 4 o'clock and then have nothing assigned left to do, but you'd be able to go and see what hasn't been assigned, pick it up and start to do it. Jean-Yves, I'm just saying you're too busy.
I know.
So that's kind of our work in front of us, and we're going to start a beta program on the task capability late this year, so look for that. And this is just the bucket list for us of lots of longer term items that we want to address in the future. Then we'll start to look at it more next year. So come talk to us, and that's it for me, and I went way over time.
Thank you.
Thank you.
I'm good. I'll just use the handheld mic. Great. Well, thanks, Dave. So my name's Eric Gaxtetter, and I'm going to talk a bit about high accuracy GNSS. So high accuracy users in here, just to get some kind of idea. RTK users in here. Okay, good crowd. So I'm probably going to ask you to advance. There you go. Thanks. So I'm going to talk about probably 3 things this morning or this afternoon, and And one of them is I've been doing this for 30 plus years now, and I wrote for GPS World Magazine for probably 10 years about high accuracy. I was their contributing editor, and was able to travel around the world, consuming different ideas and technologies about high accuracy. And I have to say that in my 30 years of doing this, this is sort of one of the really handful of developments that I really thought was amazing in high accuracy GNSS technology. And it's the new Galileo service. And so over the years, I probably started 10, 15 years ago, I would go over to Prague, which is actually was in Brussels to begin with. The EU, their Galileo program was based in Brussels, and then probably 7 or 8 years ago, it transferred to Prague in the Czech Republic. And so about every 2 or 3 years, I go over there and consult with them and sort of give the US perspective about, what the needs are in the US market, or what people think about in the US market for high accuracy. And the subject of high accuracy always came up. Hey, what kind of demand is there for high accuracy GNSS in the US? And I said, it's there. I said, people are using RTK already. They're using SBAS with WAS. So I think the demand is there. And so they had this capability that was really unique. And there was this debate within the organization throughout the years of whether they charged for it or not. So initially, Galileo was going to charge for this service, this high accuracy service. And finally, they at one point, they decided we're not going to charge for it. And so the last meeting I had with them was probably 2 years ago, or 2 or 3 years ago, just prior to COVID, where I was over in Prague. And they said, look, we're getting ready to deploy. Interesting, just from a business standpoint, they were afraid of competing with private industry because Galileo is a public entity. Granted, it's a consortium of 27 EU countries, but it's a public entity per se. And so they were worried about competing with private services because there's satellite services, like even John Eve offers an Atlas service, a satellite subscription service for high accuracy. And so they were concerned about the debate. So anyway, they go ahead and deployed it. It was deployed this year in beta. And I think maybe it's still in beta. John Eve can talk about that a little bit. But it is deployed and it's usable today. And so it was pretty exciting. And what it means is, in a nutshell, I've got a few bullet points here, is you can get sub-foot accuracy in real time. Okay, so it's sort of in between SBAS, which is sub-meter, right? So SBAS, which is WAS, is anywhere between 10 centimeters and a meter, depending on how the sun is behaving and how the ionosphere is behaving. So some days WAS looks really great, some days it doesn't look so great. But then a step down from that is RTK at the inch level, okay? But what's required for RTK? Connectivity, right? You have to be able to internet connectivity, you gotta be able to connect to a base station. So this is sort of in between those two. Remember, WAS doesn't require connectivity at all. It's the FAA created a system to broadcast corrections from a geosynchronous satellite. It's all transparent to you, but it just works. Galileo is the same way, but at a high accuracy level, right? So again, WAS is sort of a sub-meter type of accuracy solution, and Galileo Haas is a sub-foot and even better. And I've got some data that I've collected to show you sort of what the performance is that you could expect. So the beauty of this, and this is sort of the Achilles heel of RTK, is that it doesn't require an internet connection at all, okay? So what happens is that Galileo satellites have a different frequency, a different channel dedicated to provide corrections to the user on the ground. And all you need is the right kind of receiver to receive those corrections and apply them. So you could be out in West Texas where there's just no cell coverage at all and be able to use this high accuracy service. Free. I mean, that's kind of the cool thing about it. It's completely free. And there's coverage at extreme altitude or extreme latitudes. Okay, so with WAS, if you've ever experienced it, and I've been up in northern Alaska and I've been to South America, if you get in those extreme latitudes, WAS becomes much more difficult. And why is that? It's because the WAS geosynchronous satellites are above the equator, right? They're at 0 latitude. And the further north or south you get, what happens? That satellite gets lower on the horizon. You have a more difficult time receiving that correction from the WAS satellite. Galileo Haas is different than that. It's broadcast from each Galileo satellite, which is 24-ish or so at any one time. And so the correction is broadcast from each one of the satellites, so no matter which latitude you're at. Another limitation of WAS is if I'm in Alaska, for example, or even down here in the continental US, and I'm in a a valley, of, say a river valley with mountains around. I'm from Oregon, so there's lots of topography in Oregon. And your connection or your visibility to that one WAS satellite is interrupted, you're not going to be able to receive that WAS correction. With the Galileo HAS system, it's broadcast from each Galileo satellite, so no matter where you are, you're going to at least get access to one Galileo satellite, right? That's going to provide that correction. That's really the two key things here are, in my mind, that make it really unique. Well, and in addition to the accuracy, is no internet connection needed, and the correction is broadcast from every Galileo satellite, okay? So the bottom one here, the bottom point is, will it replace RTK? Well, no. RTK is sort of, I remember Charlie Trimble, who founded Trimble Navigation 20 or 30 years ago, I was talking to him and he said, you know, accuracy is addictive, you know, and it is. Once you've sort of gone down to RTK level and you've experienced the RTK, you know, fixed in 2 seconds at a centimeter, it's hard to go back. But I think there's a sweet spot in there for Galileo HAS, you know, even to be a augmentation to RTK, and Johnny, you know, he'll probably figure out a way to exploit that so that if you're in, you know, some part of the world that's got spotty internet coverage and you lose RTK, Galileo HAS can fill in automatically, transparent to you in the field, so you don't even feel it, the transit. You don't even feel the loss of cell connectivity. You can just transition between RTK and HAS back and forth. So that's a picture. So it takes a specific receiver to receive this Galileo HAS correction. And EOS had planned ahead of time. They knew this was coming. So they developed the Aero Gold Plus, which we've tested. It's got a special antenna because it's got a different frequency. You'll see it on another slide here. That the Galileo set is broadcasting that correction on. But that's the picture of the receiver. It's just, you know, it's a 1 pound receiver on top of a range pole with a relatively small antenna on it. Next slide, please. So obviously the first thing I want to do as a person who enjoys playing with technology is I want to test it. And so I tested it earlier this year. This is probably March timeframe, I think. So one of the gotchas of the Galileo HAS service is what they call convergence time, right? So if you've used RTK, you know, once you connect to the RTK base and you're connected, it's 2 or 3 seconds and your fixed solution, 1 centimeter. Galileo HAS isn't like that. It takes convergence time to get there. Okay, what is that convergence time? Right? How long does it take? Well, here's my experiments from my antenna up in Oregon, my roof antenna. So after about 10 minutes, I'm down to 1 foot level, okay? And that's convergence. And what convergence means, it's a one-time thing. You let it sit for, in this case, 10 minutes. It will achieve that accuracy. Then you can start moving around. And actually, you don't have to be stationary when you're converging. You can put it on the roof of your truck, be driving to a site, and it can be converging during that time. You don't have to be stationary for it to do that. But the longer you allow it to converge, the better accuracy it gets. So in this case, after 10 minutes, I was about 30 centimeters. At 15 minutes, I'm at 23 centimeters. And if I waited, I think 45 minutes, I was down to about 11 centimeters, okay? So 45 minutes, 11 centimeters, about 4 inches, right? And once you allow it to do that, then you're good for the rest of the day or until you power it down or otherwise interfere with the antenna. And then a few things here. So if you look on that screen on the left, I hope it's big enough. So this shows after about an hour of convergence time. And so about 10 centimeter accuracy, so 4 inches. And we know that the correction is coming from the Galileo HAS system by this field in the lower right-hand corner. So we call it the differential station ID. Every RTK base station, WAS, whatever you're using, has broadcast a differential station ID. So then you know which correction source you're using, right, at any one particular time. So that's just a screen to show you what during my experimentation. And I played with it many, many times, but this is pretty typical. And Johnny may want to comment that in different regions of the world, you'll have different performance expectations. This is one in Oregon. I also got an office in Florida. We tried it there and had similar results. And I think throughout continental US, we should see something pretty consistent. And Galileo is not done with this. This is sort of the first or second phase. They've got another phase where they're going to reduce this convergence time. And so even better. But I think probably the maximum will be is probably 5 to 10 minutes. That'll be the best you'll ever get. You'll start to converge. So for that reason, it will never compete with RTK, either on a convergence time or an accuracy level. But man, I tell you, to be able to get solid sub-foot accuracy with no internet connectivity anywhere in the US, it's pretty impressive actually. So I wanted to transition a little bit. This is somewhat related, but a new subject here. So it's, because there's a lot of confusion still in the high accuracy market of, hey, people think, okay, it supports 4 constellations now. So remember, there's 4 global constellations of satellites now. And this is huge from 10 years ago, right? So now it's GPS, GLONASS, which is the Russians, Beidou, which is the Chinese, and Galileo, which is the Europeans. They've all launched their own systems. They're all pretty good systems. We would say probably the best is GPS, obviously. But maybe Galileo second, Beidou third, GLONASS is a, you know, next. But they're all very useful. So the key is that your receiver, if you really want to optimize performance, and I'm not talking about accuracy. This doesn't help accuracy. Having more satellites doesn't help accuracy. What does it help? What happened for you folks who used to use GPS only, and then you start using GLONASS? What helped? All of a sudden you could work faster, right? You didn't have to stop during the day. And so these 2 extra constellations, the Chinese and the Europeans, accelerate that even more. And we have this test course, like I mentioned, up in Oregon. We have some nasty points under some heavy trees. We've done thousands of points of experiments, and we've really proven that 4 constellations using those is about a 50% productivity increase over just using 2 of those 2 constellations, right? And that's really, it's not about more accuracy, it's about being able to get more done during the day. And so if you start looking, sorry, I'm going back. If you start looking you want to look for a receiver that supports all these, because there's lots of receivers out there that say they support 4 constellations, but they support a subset of they pick and choose because either the receiver's not powerful enough or the CPU they're using is not powerful enough to process data from all these signals. But ideally you want a receiver that uses all these signals and all these constellations. That'll give you the max performance in the field. Yeah, you may have to spend a little bit more money on the receiver to begin with, but it'll pay for it in your operational costs and frustration, because the users will be less frustrated and be able to work faster in the field, right? And it'll pay for it, because these receivers are good for 7 to 10 years. You know, they won't be obsolete in 3. Next slide, please. So the last, I guess this is an extension of the last slide. So it's all about productivity. I covered that. More satellite data means faster fixing, right? Which you've seen in our take views. Less frustration by users. The whole CapEx versus OpEx. You know, if you can spend more on CapEx, capital equipment in the beginning, that's going to be more productive. It's going to pay more than pay for itself. We've got so many ROI cases where we've proven to folks, if you spend a bit more money up front, you're going to save that in loads in operational costs down the road and reduce user frustration. Yeah, this is a great example right here. This picture on the left, this is down an alleyway in Salt Lake City when we were doing some field tests with a utility company. And they were saying, look, we can't get a solution down this alleyway. It's 4-story buildings on either side. They were using 2 constellations during that time. We went to 4 constellations. We're able to get a solution in there now, right? That's sort of a difference maker in that kind of a tough environment. Out in the wide open in the parking lot, whether you're using GPS only or all 4 constellations, probably not going to make a difference. It's when you start working these sort of challenging environments, that's where a high performance 4 constellation receiver really makes a productivity difference. Next one, please. So the last subject, the 3rd subject, is base stations. And I've talked, if you watched me speak about this before, I've talked a lot about setting up your own base station. And this is still, it's a true story today, and it's the same, and I'll give you an example. There's certain states, let's say there's probably 25 states now that have their own free RTK systems, the DOT systems, right? And I've used them, I use probably nearly all of them at one point or another. But we see some of the DOTs aren't keeping up with the latest technology. I'm not blaming them because it's expensive, but a lot of them are still only broadcasting 2 constellations, or a subset of those, or a subset of 3. And it still makes a lot of sense, and we still have a lot of customers establishing their own base stations, even in areas where there's free RTK with the DOT today. And Missouri is a great example. I'm not going to pick on any Missourians, but Missouri, we've done quite a bit down there where they still only support 2 constellations, and we've installed base stations, and the users have said, hey, we've been using you know, the MDOT for 4 years now, and you know, this difference between having our own base and using the DOT is amazing in the field. I mean, you're talking about 50% increase in productivity with RTK. Just changing out base station. It's not, setting up a base station is not like it used to be. It used to be a $50,000 endeavor and high maintenance. I mean, you can install one for $12,000 and then no maintenance. I mean, they're really maintenance free these days. And a quote from them, they said it's one of the best investments we ever made. We've installed hundreds of these across the U.S. Faster, reliable RTK base. You're supporting all constellations, so you're exploiting all those signals that I displayed there before. So, next slide. Is that the last one? And just you know, I talk about base stations, and people say, well, "What's that?" It's sort of an archaic term. This is actually what one looks like, right? So, on the right side of the screen is it's just a weatherproof box tacked on the side of a building roof with the antenna just U-bolted or bolted to the wall. It's got a Verizon on the right side of the screen. You see it's got an EOS receiver as its GNSS brain, and then up above that is a SIM card modem. Right, you stick in an AT&T SIM card or a T-Mobile or whatever. It doesn't matter which SIM card. And all your internet connectivity is done through that SIM card. And so it's completely separate from corporate networks. So you don't have to get IT involved in that respect to get their approval. There's no vulnerabilities. No one's going to hack into this. They don't care about what this is. But that's all it looks like. They're pretty straightforward. And once they're fired up and running, they just go. You don't have to, there's really no maintenance to do at all in them at all. Just supply of power. That's the key thing. I think that's my last slide, right?
Yeah.
Yep, great. Hey, thanks. I guess we'll go to Johnny now.
Thank you, Eric. I'm going to talk a little bit more about Galileo HAS. Because I need my glasses. Thank you. When I would say a couple of years ago, 2 years ago, almost 2 years ago, we came out with the Arrow Go Plus receiver in order to be in anticipation of the Galileo E6 signal, the high accuracy service coming up. And it was there waiting for the system to be ready. You know, we've been in talks with the European Space Agency for a long time, and then when it came out, in January of this year, they released phase 1. It went from phase 0 to phase 1, which is the beta phase. Phase 0 was feasibility. Phase 1 was actually, here's beta, have user tested, and just fine-tune the system before it goes to the final phase, which is phase 2. So we promoted this immediately when it was available. Our firmware was tuned up immediately, released to beta testers in the field. We did testing and promoted it a little bit. And then European Union Agency for the Space Program saw that and say, hey, we need you for Galileo HAS Day, that was 2 weeks ago in Madrid, to present to us your results, your testing, and also talk to us about what the mapping community wants to have. What are the benefits they can get from such a signal? So I was invited there in Madrid to speak, and I went there, and I learned a lot, which I'm going to share with you also. But basically, I just want to go a quick overview of how Galileo's system works. Galileo, the HAS, the High Accuracy Service, uses a different form of corrections that you guys are familiar with. It's called PPP corrections. It's different from the local corrections that you get from an RTK network, RTK base station, which are, you connect to it, you get the corrections, and you get immediate results, instantaneous convergence. But when using PPP, there's no base station around you. It uses different types of information. It uses clock corrections, satellite orbit correction. It uses code biases, phase biases. Don't worry if you don't understand. I mean, I thought I understand myself too. And it also uses basic atmospheric correction. So basically, these are global corrections that are not really conventional. It was put in place by the Natural Resources of Canada back in the 80s, and people are more and more using PPP. So advantage, no base station. Disadvantage, a little time to convergence, because it uses carrier phase. It has to do a whole bunch of mathematics before it can converge to a solution, a good solution. So it takes some time. So the way the architecture of the system is, you got a satellite in space, you got base station, monitoring stations around the world, monitoring the Galileo satellites, computing all this, pushing it to a station, processes everything, and that's in Madrid. And after that, they push it out to the satellites, so the satellite can broadcast those messages. And the beauty is that each satellite participates in the overall message. They send out bits and pieces of message, each of them every second. So even if you're lacking some satellites, the other ones will be receiving some information from the other ones and get a good convergence. That's called a signal in space. And they also have the DDI, data distribution over the internet, but I don't see any of our users using that for mapping applications, really. It's a little bit more complicated because even if you think you have a receiver, you're going to get the corrections via the internet. It's not the same format as standard RTCM that you know of. It is RTCM, but they have different messages that are for the PPP corrections. So signal in space is really what we want. So here are the phases of Galileo. Phase 0, we're currently in phase 1. And phase 2 will come. I mean, they're trying to do it as fast as they can, but I think we're about at least 1.5 to 2 years down the line. But in the meantime, they don't stop working. They're fixing a couple of bugs, data gaps, clock jumps, and they're gonna increase the number of stations around the world in order to get ready for phase 2. So there's gonna be a lot of work being done over this year, next year, and we'll see improvement. So when we get to phase 2, that's going to be basically declared operational. And we're going to have 2 service levels. One of them in Europe is going to call SLA, service level 2, I'm sorry. And the convergence time will be less than 100 seconds, less than 2 minutes. And you'll be up and running, getting some, 10 to 15 centimeter accuracy, about 3-4 inches. And service level 1 will be for the, I'm always confused with that. Okay, service level, I'm sorry. Is for the rest of the world. They're going to have less monitoring stations around, but the convergence time is going to be less than 5 minutes. So within 5 minutes, we will go down to within 10, 15 centimeters. So that's how the system is designed, how the system is planned, and this is what will happen in phase 2. Lots of advantages. Basically, it uses corrections for GPS and Galileo constellations over multiple frequencies. Initially, it was supposed to be L1, L5 GPS, but then it was a big surprise to see that they're supporting L1, L2, and L5. L5 GPS don't have enough satellites yet in the modernization of GPS. So it's coming, about 15, 16 satellites out of 31 that needs to be modernized, but it's going to come soon. L2, they didn't even go to L2C yet. They're still with L2, and the new Siberian signal is going to get more satellites also, and then they will transition to the new L2C signal, which is very good. So triple frequency for GPS. And for Galileo, they have E1 and 2 and their satellites. So there's no plan to support GLONASS and Beidou in their systems. It's going to be like a dual constellation solution if you want. And initially, I did the quick testing like Eric did in his roof. We have a roof, another roof in our headquarters in Montreal. And basically, I logged for 18 hours. And I was surprised to see the results. It took a while to get down to foot level accuracy. That was expected. Because no phase bias are currently being broadcast. It will be broadcast later this year. So conversion takes longer. But after that, after I would say less than an hour, we get within really the 20 centimeter range. And then the following day, I came back to the office, and then it ran 20 hours, 18 hours, looked at the results. The average was about 5, 6, 7 centimeters, about 2, 3 inches accuracy. That was unexpected. That was the very first test that I did. And we decided to do testing, like multiple logs constantly. So Europe, Canada, we did some logging. Like 100, here what you see here are 190 runs of 1 hour each. And you can see that in Europe, you go down to, let's say, 30 centimeters within 10 minutes currently, even in phase 1. And it gets better in time. And in Canada, it takes about, I would say, roughly 20 minutes to go to foot level accuracy. You instantaneously go to sub-meter, but then after that, it gets better with time. And this is also expected right now. So this is the difference between currently Europe and the rest of the world. And the reason is because there are not too many, they have used what they have today. All the European, territories around the world of the European Union were used for phase 1 testing. So for example, in Canada, there's a small island called Saint-Pierre-et-Miquelon, which is a French possession, and they installed a monitoring station here, there in Canada. So, and with that, they create atmospheric models, and that helps in the conversions. So this is the reason. Now they're going to be adding their work for the next 2 years is going to be to add stations all over the world in order to decrease this convergence time. And right now, there's what you see here is over Asia. That doesn't mean you cannot use it over Australia. It's just that because of the lack of base station, conversions might take a bit longer, or don't always expect sub-foot in a timely manner. But this is what the system is today. Now, the beauty of this is that you can start using it right now. Those of you who have the OWL Gold Plus receivers, because you do need the E6 frequency, which requires a special antenna, special receiver to support all those signals, you can use it today. We have beta firmware that you can request, and we show you how to update it, your receiver, and start using it in the field. And whenever you want to use RTK, you just push it RTK. If you're remote, then it will fall back and go back to HAS. And these are, for example, one of the very early adopters with National Park Service that have a few hundred, a few hundred of those Gold Plus receivers they acquired. And they started using it in the field, give us feedback. And when I presented that to the USPA, European Union, they were astonished. They couldn't believe that people in the mapping community outside of Europe were waiting for them. And I got almost a standing ovation when I was there. Thanks to you guys. And then they've been using it, and Neil has been promoting it also in MPS, and it doesn't cost anything, so just try it. But there are things to know. The things to know is that right now, conversions is a bit long. It will get better as the months that we go back into the years and next year. Just let it run when you getting set up to go in the field, when your work, unload the receiver from your truck, leave it there, do your stuff, and then 10, 15 minutes later, pick it up and start doing your job. You will be sub-foot accuracy with that. So there's a lot of work that we'll be doing in tuning this firmware constantly over the years. So those of you who are interested in the testing, feel free. It's free, and we will support you also. And I want to thank you all for being present. It's really a pleasure.